10.5 worked out problems. Use the integral test to determine the convergence, divergence of the series. Well, yeah, that's third root of n, so that's n to the 1/3, which means it's going to diverge. But hey, I'm here to help. Limit, we'll go with a, goes to infinity, and we'll write this from 1 to a, n to the 1/3 dn. Really could have called that x to make my life easier because I'm used to that, but hey, that's fine. Limit as a goes to infinity, add 1, 4/3, divide by that, get 3/4. I did that wrong. Oh, that's a negative 1/3, that's why. And when I get 2/3, divide by that, get 3/2. So 3 n to the 2/3 over 2, 1 to a, which is 3 times infinity to the 2/3 minus 3 times 1. Don't know why I put the 3 in there twice, over 2, which is infinity, which means it diverges. Now this is n to the negative 3/2. That's going to be 1 over n to 3/2. This one's going to work. So limit as b goes to infinity, integral 1 to b, n to the negative 3/2 dn. Add 1, negative 1/2, divide by negative 1/2, negative 2. Equals negative 2 over square root of infinity minus negative 2 over square root of 1, which is 0 plus 2. Converges. All right. Use the limit comparison test. This is going to be a 1 over n. This is going to fail. But whatever. So that's my a of n. And then on the bottom, I put my b of n. This is limit as n goes to infinity of 3n minus 1 times n over n squared plus 1. Three n squared minus n over n squared plus 1. Since that's infinity over infinity, do that whole derivative thing, we get 6n minus 1 over 2n, which is infinity over infinity, which is 6 over 2, which limit as n goes to infinity of 3 equals 3. So since this diverges, then diverges. Yeah, no, I agree. It's kind of complete and total nightmare. So let's compare this. Sum of 2/3 to the n, which we know converges is geometric, blah, 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 blah. Limit n goes to infinity, 2 to the n, 3 to the n, plus 1 over, yeah, I'll write this out because I think it might be easier to understand it that way. Equals limit n goes to infinity, cancel, cancel, 3 to the n over 3 to the n plus 1. As that goes to infinity, of 3 to the n over 3 to the n, don't know why I wrote this twice, equals 1, converges. I'm not writing it out again. This converges, therefore, this converges. We compared to it and got between 0 and infinity. Determine whether the series converges or diverges, maybe more than one correct way, yada, yada. Alrighty. Here's the fun part for me. Diverges, diverges. Done. So we can do a limit comparison test here. So 1 over square root of n, which we know diverges. Limit n goes to infinity, 3 over n to the 1/2 over 1 or n to the 1/2 equals 3, diverges. Many you'll be like, well, how do we prove that? You can make that assumption that we know that one diverges. It's clean. It doesn't have a bunch of variables and stuff on there, so you're good to go with that. So this one we will compare to one over n, which we know diverges. Limit infinity 1 over 2n minus 1, 1 over n. Limit goes to infinity, n over 2n minus 1. That's infinity over infinity, so we do that whole derivative thing, and we get 1/2, therefore it diverges. About as close to doing proofs in calculus as I ever hope to get. Determine whether the series diverges, converges, maybe more one way, yeah, whatever. All right, this is a geometric, and R is 1 over ln of 3. 1 over ln of 3 is 0.910, which is less than 1, converges. I love problems. This one we're going to compare, which seems odd, but I believe I've done a problem like this before, to sum of 1 over n. Limit as n approaches infinity. So we get n sine of 1 over n over 1 over n, which will be, let's see, 0 times infinity over 0, basically 0 over 0. So we need to do that whole derivative thing. I don't like the solution I came up with. Gives me And we're going to go with infinity times 0 over 0, which is kind of one of those moments. So I'm going to L'Hopital it. Oh wait, we got two variables here. Yeah, I know what I did last time. I don't like that. I'm going to cross that out. It says is like the limit as n approaches infinity of n. I see what I did. Times sine of 1 over n over 1 over n. That's 0 over 0. And I've done this before where I've gotten 1. If you're like, whoa, how did you do that? Go ahead and blast this out, because you can do the limit here and a limit there. You'll get 1 here. So you're going to do the derivative. You're going to get infinity. It's going to cancel. You're going to get sine of 0. No, you're going to get cosine of 0, so you get 1. Anyway, that basically gets you the limit of n goes to infinity of n times 1. So that's infinity. Therefore, since that diverges, this diverges. Weak logic, I agree, but you know, what are you gonna do? All right, so let's just figure this out quick. This will converge because we got end of the third on top and end of the fifth on bottom. Compare to sum of, oh, that was horrible, 1 over n squared. Limit n approaches infinity. 5n to the third minus 3n over n squared, n plus 2, n squared plus 5 over 1 over n squared. Okay, by the way, these cancel. Equals limit as n goes to infinity of 5n to the third minus 3n over n to the third plus, yeah, I actually did multiply this out. Lord, that's lame. 5n plus 10, which will give me 5. After all the work we do, we know it's going to be 5. Don't believe me? Take derivative till you get it all the way down. You'll see it's going to be 5. So since this converges. Here we're going to use the nth term test for k, because the 1 becomes kind of irrelevant. This becomes 1/3 eventually. And that means the limit as we get out to a bazillion is 1/3. We're adding plus 1/3, plus 1/3, plus 1/3. Okay, that doesn't work. Limit as n goes to infinity of 3n minus 1 plus 1 over 3n is 1/3. Well, how did you get that? Well, we could take the derivative. Let's leave that off for now. So we get infinity over infinity. So let's take derivative. We would get 3 to the n minus 1 times ln of 3 over 3 to the n times ln of 3. Cancel, 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 cancel equals 1/3. Since it's not going to 0, it diverges. Notice how often I shortcut this. You know, converges, diverges. You should get to that point because you're not going to have to do this on a test. You just have to be fast at it. This is a 1 over square root of n, but since it's alternating, it's going to converge. So let's go with alternating series test. So we need to say, what's the limit as we go out to infinity? And I believe we do absolute value. And that's infinity over infinity, and then we take derivative, 1/2 whole squared and 1. So we get 1 over, well, we get 1/2 technically. We're gonna do it right. Yeah, something like that. Which, as n goes to infinity, equals 0. Great, so alternating series test, it's tending to 0. Very nice. Now we have to say what's U1. So the first term, by the way, it's alternating. If 1 is my notes are wrong. 1 plus 1 over 1 plus 1 equals 1. U of 2 equals wow, my notes make no sense. Square root of 2 plus 1 over 2, which is 2 point, no, that's not right, for 3, which is like 2.4 over 3. So that's less than 1. So we've gone from a bigger to a smaller, and we see that it's going to constantly get smaller. So since we have -1 to the n plus 1, meaning it alternates, this converges. That's really busy for an actual test. You'd be like, oh, it's 1 over square root of n, alternating, done. So this is the same as n squared n over n squared, n minus 1 over n squared. This, of course, is going to diverge. We're going to compare to that. Limit as n goes to infinity, n minus 1 over n squared over 1 over n, which is the same as the limit as n goes to infinity, n minus 1 over n, which equals 1. All right, that diverges, and that diverges. Yes, my hand is tired, in case you were wondering. The sacrifices I make for my students, I'll tell you, I'm a hell of a guy. Do I recommend doing all these? Yeah, I actually do. It's challenging stuff. Converges absolutely, converges conditionally, diverges, give reasons, blah, 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 blah. This is a geometric series. It's going up by -0.1 every time. R equals -1/10. Find a bound for the truncation error. So we actually get this error thing in here, which is kind of nice. And that means it converges. Absolutely. You might be like, whoa, 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 whoa. What about the whole alternating part? It didn't need the alternating part to get across the finish line. And if we're going to go with truncation error, all right, then we have an absolute value thing. Well, not necessarily. What do we got here? -1 to the, for the 99 terms, to the 100th. In this case, it's n plus 1, so it's 101 times 0.1 to the 100th, since that's only in men, which is -1 over 10 to the 100th. If we're going with absolute values, that would be 1 over 10 to the 100th. It's a really small number. Whatever. Let's do ratio test. Limit as n approaches infinity. Why am I writing this out? U of n plus 1 over u of n. Limit n approaches infinity. N plus 1 squared. 2/3 to the n plus 1. N squared. 2 over 3 to the n. All right, so as we get to infinity, these two cancel out. It's n squared over n squared, and this just leaves me with 1 over 2/3. No, 2/3 on top. Eyesight's definitely failing. Equals limit, n goes to infinity, 2/3, which is 2/3. So this converges absolutely. I don't have any x's in here. I have to check out. All right, keep hacking away, right? Term whether the series converges absolutely, conditionally, it diverges, give reasons. All right, this is horrible. Since sine of n oscillates from -1 to 1, all right, we can change this to sum n equals 1 to infinity of -1 to the n plus 1. Sorry for the hash of handwriting. Times 1 over n squared. And this is absolutely convergent. And if it really helps you, you can say by p-test. And this is actually what I would have done for almost all the problems on the previous couple pages. P-test done. Same kind of deal here, since cosine oscillates from -1 to 1. We can make this n equals 1 to infinity, 1 over n to the 3/2. Same deal, absolutely. Converges absolutely is what I really should say. Convergent by p-series test. And let's see what's going on here. So square root of m, square root of n. I can ignore the plus 1. It's 2 square root of n. This is gonna only converge because of the negative. So this is conditionally convergent. All right, as n tends to infinity, this function becomes sine of n equals 1 to infinity, -1 to the n over woof. Boy, I make a lot of mistakes in my notes. 2 root n. Root n plus root n is 2 root n's. I wrote n before. Root n plus root n does not equal n. That's so weird. 2 root n which is, and I've done this before, bring the 1/2 out front. N equals 1 to infinity, -1 to the n over n to the 1/2, which means this is conditionally convergent. It wouldn't converge if it wasn't for that negative. Conditionally convergent. Again, I would normally write converge as conditionally. And again, by P-series test. Whew. Working for a living. So, explain how to rearrange terms, form a divergence series, the convergence to 4. I thought I deleted these. Darn. We don't do that. We skipped it in our notes on purpose. It's a neat little thing, but no, moving on. Find the interval of convergence of the series with value as x does absolutely conditionally. All right, so here's your, finally, problems that you're really going to see. So we're going to do a ratio test. Limit as n approaches infinity. X plus 5. In my original notes, I forgot the whole absolute value thing, which is upsetting. X plus 5 over n equals x plus 5. So we do all this fun stuff. X plus 5 less than 1. -1 less than x plus 5 less than 1. -6 less than x less than -4. Now we plug them in. -6 goes in here. -6 plus 5. And be careful here to see how quickly this goes wrong. Is -1. Hey, -1 to the n. It alternates. No, it doesn't. There's no n on the bottom. So -6. No. -4. 1 to the n. No. So there we are. We have the R equals 1. IOC is -6 to -4. Absolutely convergent. -6, -4. Conditionally convergent. None. No values. All right, so just notice there's nothing on the bottom. Here there's an n on the bottom, so yeah, this is where things get a little more interesting. Ratio test. And by the way, I shouldn't really have to write this. Ratio tests. If you're asking for interval of convergence, we're doing ratio tests. So limit as n goes to infinity, 3x minus 2 to the n plus 1 over n plus 1, n over, all right, 3x minus 2 to the n. Hold on, equals 3x plus minus 2. So let's go with -1 less than 3x minus 2 less than 1. Add 2, 1 less than 3x less than 3, divide by 3. Okay, divide by 3. And we get our interval of convergence. 1. Now let's check the endpoints. 1/3. Splitting 1/3, and we get 1 minus 2. That's -1. Yeah, that works. And then we try 1, which you already know is not going to work. 3 minus 2 is 1. So now I got to figure out how to write all this in here. R equals 1/3. IOC is 1/3, 1. Absolutely convergent 1/3 to 1. Conditionally convergent at 1/3. Onwards. Limit n goes to infinity of n plus 1 x to the n plus 1 n plus 3 n plus 2. Wow, what a mess. N plus 2 over n x to the n. Whew. All said and done, n plus 2, n plus 3, and n plus 1, x. So r equals 1, interval of convergence. Actually, I can't finish that, -1 to 1. Let's check -1. Now this is going to get weird. -1 gives us alternating on top, but we have n over n, so it doesn't matter. These are both no's. Which is, for some very bizarre reason, oddly satisfying. And then absolutely convergent, -1 to 1. Conditionally convergent, none. Limit n goes to infinity, x to the 2n plus 2. I'm going to go with 2n plus 3 over, this one's going to be conditional. This is going to be absolutely everywhere because we got a factorial on the bottom. N plus 1 factorial times n factorial over x to the 2n plus 1. Equals, we got an n plus 1 on the bottom, x squared on top. All right, as this goes to infinity, this is 0. So it doesn't matter what I put in for x, it's going to converge everywhere. R equals 0. Interval of convergence is from -infinity to infinity. Absolutely convergent from -infinity to infinity, and then conditionally convergent, none. Oof. Wow, thank goodness, last page. Interval of convergence for the series. Look at all of this work. Okay, same deal we just did. Limit n goes to infinity, n plus 1, x to the n plus 1, 4 to the n plus 1. Oh, goodness gracious. N plus 1 squared plus 1, 4 to the n squared plus 1. N x to the n. Okay, n squared by. It's going to get me x over 4. -1 less than x over 4 less than 1. -4 less than x less than 4. Radius equals 4. -4. Holy cow, look at all this mess. N over n squared gives me 1 over n. Great. -4 to the n is like -1 to the n and 4 to the n. They cancel. Yeah. So -4 works. 4 just cancels, no. Off we go. Wow. Radius equals 1, pardon me, 4. Can write down my radius here. IOC -4 to 4. Absolutely convergent. -4 to 4. Conditionally convergent. -4. Wow, that's a lot of work. Okay, onwards. Limit n goes to infinity. N plus 1 factorial. This is going to diverge everywhere, I think, because that n factorial is going to cause problems. X minus 4 to the n plus 1. N factorial. X minus 4 to the n, which is going to equal n plus 1 times x minus 4. Getting tight on space there. So the limit equals infinity. This only work when x equals 0. So if a radius equals 0, you have a interval of convergence. When does that equal 0? When I put in x equals 4. You have absolutely convergent only at 4 and conditionally convergent none. All right, limit n goes to infinity, 4x minus 5 to the 2n plus 3. Over, this is going to have some conditional convergence because we got into the 3 halves. Actually, no, it's going to converge everywhere. So both endpoints should work. N plus 1 to the 3 halves, n to the 3 halves, 4x minus 5 to the 2n plus 1. Equals, cancel, cancel, 4x minus 5 squared. So we get that whole 4x minus 5 squared is less than 1, which just becomes 4x minus 5 is between these two. Add 5, 4 is less than 4x, it's less than 6, divided by 4, 1 is less than, x is less than 3 halves. Okay, check our endpoints. 1. Oh, back up here. Formula -1, whatever. This is going to converge. I don't need the 1. All right. Yes, but not because of conditional. And same thing with 3 halves. Yes, but not because it needed the alternating aspect of it. So here we go. R equals 1/4. Interval of convergence. Works on all ends, 1 3 halves. And it's absolutely convergent on that interval. And conditionally convergent, none. Limit n goes to infinity. Apologize, I missed that at the end there. This is weird. Limit x is going to diverge. Except maybe at the one spot where it equals 0. Let's go find out. Ln of x to the n plus 1 ln of x to the n, which is just ln of x. There's no n in here, so yeah, I take back what I said. This is going to work in certain spots. When L of x is basically between -1 and 1. -1 less than ln of x less than 1, e all 3. So 1 over e less than x less than e. Let's check our endpoints. Plug in a 1 over e. We get I'm so confused. 1 over e. That's e to the negative first. They cancel. I'm left with -1 to the n. And that diverges. It's not 1 over n with a -1. It's no. And then plug in e to get 0. Leave that. No, ln of e. They cancel and I get 1. Thinking of ln of 1. No. They both become -1 to the n or 1 to the n. That diverges. So here we go. Radius is e minus 1 over e over 2. How's that for math? And the interval of convergence is 1 over e, 1 over e, e. And it is absolutely convergent from 1 over e to e, and conditionally convergent, none. I hope you enjoyed that as much as I did. Good luck.